Hi, today I present ARTI5 Potsdam, a dataset and a benchmark for learning with artificial objects for improved aerial vehicle detection. My name is Immanuel Weber, I'm a PhD student at the University of Applied Sciences Koblenz. I work with Jens Bongartz and Rebana Rocha from the University of Bonn. ARTI5 Potsdam is a dataset for the detection of vehicles and aerial images. However, in contrast to other datasets for this task, we do not only have high-resolution aerial images, but also a second set of artificial images. In the following, I'm going to motivate why we created this dataset, provide some key facts about it, and then we'll close with our benchmark experiments. So why do we need new dataset for this task? On this slide, I show you some prominent examples of dataset for the task of detection of vehicles in aerial or satellite images. Looking at the titles of some of them, we see that the number of contained training samples appears to be a strong motivation to create a new dataset. However, we realize that in some real-world applications, the collections of real training samples is very difficult. To motivate this, looking on this slide here on the left, we see an image where many different cars are contained. However, even if it's one of the most common classes of vehicles out there, this class also shows a very large interclass variety by different colors and also shapes. Moving to the center, we see there's construction equipment, there are buses and trucks. Going further to the right, we do not only see cars and trucks, but also a tractor and even a boat on the road. So in reality, we may face many different types, shapes and colors, which can result in a large interclass variety, but also sometimes in a large number of classes we are potentially interested in. So collecting suitable training samples can in some applications be very difficult, time-consuming and often very costly. This gives rise to two questions. How do detectors perform with few real training samples available? And second, can artificial data potentially help us in these situations? This is what we created ARTI5 Potsdam for. It addresses situations with a lack of real annotated data, and we also see it as an option to evaluate using artificial data to jointly train our models with. As a disclaimer, we are aware that our dataset consists only of a single class. However, this single class has a relatively large interclass variety. For our real images, we rely on the ARIS-PRS 2D semantic labeling contest, specifically onto the subset of the city of Potsdam, and as the name says, it's created for the task of semantic labeling, which I'm showing here on the right. However, with simple image processing, we can derive from those yellow image areas bounding boxes, and with this procedure, we create our full-size dataset. It basically consists of the original images of the size 6000 by 6000 pixels with a ground sampling distance of 5 centimeters per pixel. It contains 24 training and 14 testing images and almost 10,000 cars. The class car is a bit more general than just strictly cars. It also contains trucks and buses. From this dataset we derived our patched version, which is basically more suitable to train actually models with, since they are typically a bit more compute restricted. We derive images of the size 600 by 600 pixels with an overlapping of 200 pixels into each direction. It contains almost 3000 training samples and a bit more than 800 testing samples. Due to the overlapping, we now have almost 27,000 cars contained in the dataset. Our artificial images are based on a very simple image generation pipeline that relies on 2D CAD drawing, which allows us to generate artificial vehicles and then randomly rotates them and place them on a simple artificial background. For details on this pipeline, I refer you to our earlier work, and in this case we use this pipeline to create images of the size 600 by 600 pixels, same ground sampling distance as before, and we created 1000 images with a total of 10,000 cars. Those cars here are based on 8 blueprints that contain smaller and larger cars, but also some smaller trucks like this one here. To sum up the content of the Potsdam dataset, we have a full-sized real dataset, we have a patched real dataset, and we have our artificial dataset. For all of those three datasets, we provide bounding boxes in an object and axis-aligned fashion, and also labels. However, as I said, those are only of the single class car. In addition, we also provide the blueprints which we use to create our artificial data from. This brings me to our experiments and baselines. For them, we use the RetinaNet with a ResNet 50 backend that is pre-trained on the ImageNet dataset. As a pre-processing, we downsample our original images to 300 by 300 pixels, since we observe that this does not decrease the detection performance significantly, however increases training efficiency. For training, we use some standard image augmentation methods like flipping and color jittering. We evaluate all experiments with the Microsoft COCO average precision with an intersection over union threshold of 50%. Now coming to our actual experiments shown here on the table, the first one is basically our calibration and reference experiment. It contains all real images and gives us an idea how an object detection network behaves with a decently sized dataset. You can also use this dataset to calibrate your methods with to get an idea if your detector performs similar than our baselines. Now, the 4 following rows are much more interesting since these are the restricted environments, and in all of these datasets we have always 1000 artificial images, but a small but increasing number of real images available. The first one, however, is the most extreme, where we do not have any real images available. This is basically the lower bound, and this gives us an idea how well the artificial images perform for our task. The 3 others have a small but increasing number of real images. We see that the detection performance rises. However, for all of those 4 experiments, there remains a gap towards our reference detection performance. And those gaps is basically what this dataset is about. It's about closing those gaps or coming closer to the reference on the top by maybe improving the artificial images or the object detection network itself. So to conclude, ArtiFive Potsdam is a dataset with joint real and artificial images. It's a benchmark to evaluate models in a restricted data regime. We also see it as a testbed for exploring artificial image generation to support the training of our models. And finally, we also see it as an option to extend other existing datasets, since the focus on the other end of dataset sizes can also be of interest for other tasks and applications. So find the dataset at this provided link here. You can also use the QR code to scan and directly access the website. If you have any questions, please feel free to ask them via email. I want to thank the DVGW, the German Technical and Scientific Association for Gas and Water, which is funding this work. And I also want to thank you for following along and the interest in our dataset.